Hello everyone, my name is Tejasvi Katiyar and my team name is Team Hawk. My team member is Mehak. My school name is Maya Devi Inter College Saramira Shivaji Nagar Kannauj. As we know, our Indian farmers does not test their soil before growing new crop, resultant they produce not well amount of grains. So we introduce a smart soil testing device which help Indian farmer to test their soil. This device is battery operated and very simple to use it. Any prior knowledge is not required for testing the soil. Farmer just insert the device into soil and reading of soil parameters show in display. Working. Initialization. When the system is powered on, the Arduino UNO initializes and starts running the code. Sensor reading. The Arduino reads data from the NPK sensor, soil pH sensor, and soil moisture sensor. These sensors are embedded in the soil to measure the respective parameters. Data processing. The raw sensor data is processed by the Arduino UNO. This may involve converting analog readings to meaningful units, applying calibration factors, if needed, and preparing the data for display. Display output. The processed data is sent to the I2C liquid crystal display, LCD, for visualization. The LCD displays information such as NPK levels, soil pH, and moisture content in an easy-to-read format. User interface. The user can observe the displayed values on the LCD screen. This information allows the user, such as a farmer or gardener, to make informed decisions regarding soil management. Calibration optional. If the system includes calibration procedures, the Arduino UNO may perform these processes to ensure accurate readings from the sensors. Feedback and action. Based on the displayed data, the user can take actions such as adjusting fertilizer application rates, irrigating the soil, or implementing other soil management practices. Continuous monitoring. The system can be designed for continuous monitoring, allowing users to track changes in soil conditions over time. This information can be valuable for long-term soil health management. Power management. The Arduino UNO manages the power supply to the system. Depending on the design, power can be supplied through a connection to a power source or a battery. Overall flow. Sensors 2. Data processing 3. Display output 4. User interface 5. Calibration action 6. Continuous monitoring. Sensors working. NPK sensor. Purpose: measures the levels of nitrogen, N, phosphorus, P, and potassium, K in the soil. How it works? The NPK sensor typically utilizes electrodes or other sensing mechanisms to analyze the concentrations of nitrogen, phosphorus, and potassium ions in the soil. These ions are crucial for plant nutrition. Soil pH sensor. Purpose: determines the acidity or alkalinity of the soil. How it works? The soil pH sensor consists of electrodes that measure the concentration of hydrogen ions in the soil. The pH level reflects whether the soil is acidic, neutral, or alkaline, influencing nutrient availability to plants. Soil moisture sensor. Purpose: measures the moisture content in the soil. How it works? Soil moisture sensors typically use probes or capacitive sensing techniques to measure the dielectric constant of the soil. The dielectric constant changes with soil moisture levels, allowing the sensor to estimate the amount of water in the soil. I2C liquid crystal display, LCD. Purpose: provides a visual interface for displaying real-time data. How it works? The I2C LCD is a type of liquid crystal display that communicates with the Arduino UNO using the I2C communication protocol. It allows the Arduino to send data for display, making it easier for users to read and interpret information about soil conditions. Arduino UNO. Purpose: acts as the central processing unit, collecting data from sensors, processing it, and controlling the display. How it works? The Arduino UNO is a microcontroller board that runs a program, written in Arduino programming language, to interact with sensors, process data, and control other components. It interfaces with sensors through analog or digital pins, communicates with the I2C LCD, and manages the overall functionality of the system.